Recording. Okay. So project number 3 involves sound recognition to turn on off a motor. So I made a video, YouTube video. So I'll play it here.
On.
I said on.
Off.
Okay, I replay.
On. Off.
So it recognized my voice command on and off. I mean, to make it simple, I made a very simple command, but it can be quite complex. IBM Watson is very good at voice recognition as well as natural language processing. So yeah, let's turn on the fan by using voice command. So that's about project number 3. So for the sound recognition, you need to record. You need to have samples of background noise. Then I recorded my command for on, my command for off. Okay. After doing that, yeah, this is the project number 3 code. This is the way to train by using your program, your Scratch program. So what this program is doing is first switch back to backdrop 1, white background. Then after collecting your sample on your ML4 Kid account, then use this block to train new machine learning model. So training is controlled by your program. But you don't know when the training is done. So your code is waiting until you get a message from the cloud that your model is ready to use. If this is true, then display training has done. The mouse cat is saying training has done. Then ask the computer to start listening. Okay? Then, if the computer hear on message, then broadcast fan on message to execute this. And when I hear fan off message, execute that. Okay, so this is about project number 3. So it seems like already 11:22. So I'll record. So if you need to leave or have a rest, that's fine, because I'll be uploading the recorded version. So this is program number 3 code, but I need to demonstrate how to record the sample data. So okay, I'll go here, then I'll first leave, then I'll log in number 2, because I stored that sound on this account. Go to your project, and sound is not here. Just a minute. Sorry, I need to go back to number 1, not number 2. Go to your project, sound on of fan. You see this? Okay. So okay, those are the visualizations of the background noise in my room. Sometimes some noise, sometimes no noise. Whenever I think this is recorded when the air conditioning system was turned on, so no aircon. So this is the visual pattern of my voice command when I speak on. And this is the visual representation of my voice command when I say off. So I'll show you how to record. Click on add example, then just click this. Then it will record the background. Because I was talking something, so that's why you saw some blue patterns there. So I'll cancel because I said something. Yes, this was background noise at that time. To sample for on sound, what I do is right after I click this microphone, I say on. So I click on. Then this is my voice pattern. Then I can add it. For off, click on add example, off. I said something quite late, so I'll cancel it. I say once more, right after I click this microphone button, off. Then add. Now I have 15, 15, 15 samples. Then I go back there. I will not retrain. Oh, I think I need to retrain. So yeah, let's train. So voice training takes slightly longer than numbers or text. So perhaps it will take around 1 or 2 minutes. And you may get some quiz questions if the training takes long. So during this time, yeah, the training has not done, training just started, then you will have a quiz time. So some questions like, without machine learning, it would be possible for search engines such as Google to exist. So the question is, search engines are using machine learning techniques? To tell the truth, no. Search engines are not using machine learning techniques. Anyway, so it's train. So now start listening. I say on, 84% confidence. On, 100% confidence. Off, 100% confidence. Off, 75% confidence. So it seems like it's working. Now, for you, time to make the app using the Scratch. So opening Scratch. Then for me, I can just load previous programs, load from my computer. And so this is about sound on a fan. So I'll select that one. And make sure I already connected EV3 and sound on off fan icon is there. Then what I want you to check is whether Lego is connected. So click on here and check whether you have the green button, green checkbox. If not, click on this, connect. Oh, something is wrong again, so I have to restart the Scratch link. I'm restarting the Scratch link. Then I'll try again, connect. Now connected. Okay. Then test the motor. So I hear the sound. Then I run the code. Then actually, I'm sorry. Because if I click this, then it will be retraining. It will be retraining by the code. So it will take some time. Then the cat will say, training has done. Then we can say something. So at this time, I want you to start project number 3. Okay, I see the cat is saying training has done because of this command. Now the system starts to listening. So I say on. Do you hear the sound? The motor is turning. And one of my pronunciation was close to off. That's why it's turned off. I say it once again. On, off. Yep. Then the screen will say on and off as the background messages. Background messages I made was something like fan off, fan on. This was displayed here. Okay, I'll give you some minutes. I want you to start. I don't think you have enough time to complete this. So one of the statement I did was close to off, 1 ohm. So the fan was turned on. Okay, so what can do would be and start the program. Okay, I'll give you some minutes, but I fear we don't have enough time. So I want you to continue after the camp to complete this project number 3 for sound on and off. Now the next topic. Okay, now project number 4 is about image recognition. For this project, we don't need EV3, and what we'll be doing is using the webcam. I'll show my papers, also rocks. Okay. Also, I cannot train this because it will take more than 5 minutes. So after sample images, you need to one problem is currently the Scratch allows only pre-recorded input images to test. So this is step to create costumes of sprite to use as image inputs to the trained model. Then the input images are stored as costumes for a sprite, and bring the each costume to recognize if the image is paper, then display paper. If a rock, display rock. That's project number 4. So I briefly, but as I mentioned, currently Scratch does not provide ways to process real-time video images from the camera. So instead of using the real-time images from the camera, I store the images into Scratch costume, and we bring each costume image to feed into the trained model. So, okay, what I'll do would be, for this one, I have to use Google Chrome because Microsoft Edge has a bug regarding the camera, orientation. So for this, I'll be using Google Chrome, and I'll log on CS2, and go to my project, image paper up, that's what I did. And those are the images I collected yesterday. So I'll show you how to collect additional images. Click on webcam. Oh, sorry, we are unable to get on the webcam to work for you because I am using it for the webinar, for the Zoom. So I'll stop video, I'll redo it. Now, I got the image. Then I show my palm to add another, paper image to represent paper. For the rock, I click on webcam, I show my fist, add. Okay, so now we have 16 sample images. Then to train, we have to do this, but I cannot do it right now because it will take more than 5 minutes. Then let's click on make, and click on Scratch 3, then opening Scratch, then click on my pre-written file, it's in here. Yep, so that's about image paper up I did yesterday. Okay, so as I showed you this code, we have forever loop, I feel, it's fine because the first will be ignored. So I think to get the, actually, I'm right. By default, you already have the first image in the costume. So let's click on this sprite, then click on costumes, then you'll find all the stored costumes. Input image to feed to the machine learning model. So what to do to add another input? Click on this cat, not click, hover over this cat, then select the camera, then you'll see this. Then you show another one, like another fist, then take a photo and save. Then that will be stored in here as costumes. Okay. Then go to the code. In the beginning, the first costume by default is stored in costume image. This costume image can be found under images, costume image. This can be fed to the machine learning model to recognize image. If that image is recognized as paper, then say paper. If not, say lock, because we have only two cases. Then wait 2 seconds, bring the next question to feed to the model. So let's run it. So if I click this, paper, another paper, rock, you see some delays, paper, rock, because image data is big, so it takes some time for the trained model to make the decision. So it will be continuously repeating, the recognition of all 7 images in my sprite costumes. Okay, so I don't think we have time to test this, but certainly it's grade 1 for you to try after the camp. So I'll stop and I'll close. Now let's go to project number 5, which is the most practical project involving Lego robots. So we collect 2 sensor data. One light sensor data, distance sensor data from the robot, and your code will send motor commands to stop or turn on the motor. So using 2 sensor data, we train the machine learning model to make decisions about this problem. So, this robot has sonar sensor, color sensor, and a motor. So the problem is, turn on the light only when the distance sensor detects something close. So light sensor dark, distance sensor detecting something near, the action is turn on the light. Otherwise, don't turn on the light, turn off the light. Okay? So to simulate dark, I just cover the light sensor with my finger. To simulate some, no one is in the room, I'll point the distance sensor toward the ceiling. So that's what I do. So in this case, it's slightly different. We have only 2 groups, turn on, turn off, but the data collection now, for each pair, we collect light sensor data as well as distance sensor data. Light, distance, light, distance. So as you can see, light sensor 0 means dark, completely dark. Distance sensor detecting something close. Then the action is turn on. Turn off case. Light sensor is detecting dark, but distance sensor is not detecting anyone. So no one is in the room, don't need to turn on the lamp. So turn off, and so on. So this project shows how to add training data, add training data by using the Scratch code. So this code is saying if number 1 is pressed, display this, repeat, and use training data for the light sensor value, distance sensor value, and make the label as turn on. That means in order to do this, you need to make the robot in this condition. That means cover the light sensor and place something near. Then the values will be recognized as turn on. That means 2 values will be going into turn on group. So the other 4 cases are here for number 3, 4 cases there, all turn off case. And this is a suggest way to automate data collection with robots. So first create project with labels, collect data items by sensor in Scratch. You need to check the collected data. And if you simply need additional samples, you can manually add, train, test. If the test case works perfectly, and the data collection process, otherwise go there and add some manually, or if necessary, re-execute the automatic program. So after collecting data, so this is the code. When green flag is clicked, train by your code the new machine learning model. When training is done, Scratch cat will say training has done. Introduce forever loop and if else loop, if else block, and introduce machine learning block to recognize number, size sensor, as well as distance sensor currently from the level robot. Then send two values to the trained model. If that model returns turn on, then turn on the motor. Okay, and if not turn on, then turn off the motor. In this case, since we are not using the actual robot, make the background white. Okay, so this is project number 5 code, and I'll just show you a pre-recorded video about this problem. So I have a pre-recorded video here. I tested yesterday, open with Wales Media.
Case number 1, light sensor detects dark and distance sensor is detecting something near. Then background becomes yellow and motor is turning. Case number 2, dark, far, and the motor stops. Background being white. Case number 3, bright, near. Or bright, far. Nothing happens. Unique case, to turn on the light will be something's near and becomes dark.
Okay, so project number 5 is doing that one. So yeah, I realized already it's 11:46. So we don't have time to practice now, but I want you to continue the completion of projects covered today. Because of this camp project assignment. So please create any new project using the machine learning techniques you have learned today. It's totally fine because many, are having problems with EV3 connection. So just ML project without level EV3 is fine. So create your project. Send me video link and script file by Sunday midnight. So you have today, Saturday, Sunday, about almost 2.5 days left to complete this project. Then I will select 2 teams who will win certificates and prizes. To get your project ideas, please watch this ML4 case overview video. Also, watch the previous 2 winners. The first place got a prize worth $50. Actually, the first place team from Hong Kong, so I sent $50 in cash using PayPal. If you are in the United States, for the second place, this team from Ann Arbor, Smart Shopper got $30 price purchased in Amazon. So I sent the price through Amazon. So you may win. So please think about your project, get some ideas from others, do the project, submit by Sunday midnight. You may win prizes. Also, it's time for you to do post survey. So I want your feedback. So I send you this post survey link by chat. Please check your, oops. Oops, I don't know why my chat is not working. Oh, I see. Everyone in meeting. Okay. I sent a post survey link on the chat. Can you complete this post survey with just 5 questions? To do this, you need to remember the PIN number you entered for the pre-survey. If you didn't do the pre-survey, that's fine. You can just complete this post-survey too. Yeah, I'll give you 30 seconds more for completing this post-survey. Okay, next. Okay, this is important actually. So I am having the next machine learning camp number 2 on Friday, August 14th from 9 to 11 a.m. If you have participated in previous camps, like the one on July 10th, as well as today, you do not need to register, right? So I'll email you the Zoom link. If you'd like to know more about machine learning camp, especially simple real-time video processing, currently what you can do is just face recognition as well as joint recognition. So so on that day, I will cover brief review because the camp will have some new people. So I'll do brief review and I'll cover face detection and post detection. So which is very fun, actually, more practical and many applications possible. So you are interested in, you don't need to register ROFES teams, but you can freely join this Friday, August 14th camp at 9 a.m. same time. It will last only 2 hours. Again, it takes time, so I'll prepare, also slide file. So I'll also send the slide file to everyone. Okay, so also if you teach, if you are a coach, if you are an instructor, yes, you may use this slide uh, as long as you give me the credit. Any questions? Okay, um, then thank you everyone for joining this camp and hope to see you someday. Goodbye.
Thank you.
Thanks,
Thank
CJ.
you.
Thank
Bye.
you.
Thank
Bye
you.
bye.
Bye.
Thanks.